Hello everyone, I am Sonal More, working as a lecturer in Electronics and Telecommunication Department, SPM Polytechnic, Kumte. Today we are going to see unit number 5. The name of the unit is Transport and Application Layer. In this particular unit, we have to discuss the point 5.2, that is network layer, logical addressing, IPv4 addresses, addresses space notations, classful and classless addressing, network addressing translation, IPv6 addresses, need for IPv6 structure, address space. Let us see the IPv4 supports the three different types of addressing modes. In the IPv4, we have to discuss the three types of addressing mode. First addressing mode is unicast addressing mode. In this unicast addressing mode, the data it can send only in one destined host, and the destination address field consists the 32-bit IP addresses of the destination host. Here the client sends data to the targeted server. Okay, this is the particular diagram for the unicast addressing mode. This is the server A and server B and server C, and this should be the client. Okay, server A, B and C, it can send the data through this client, and client again can send that particular data through this your A, B and C server. Okay, next one is broadcast addressing mode. In this type of addressing mode, the packet is addressed to all the hosts in the network segment. Okay, and the destination address field contains the special broadcast address, that is 255.255.255.255. Okay, in this way we can consider over there. Okay, when the host can seize this packet on the network, it is bound to process it, and here the client sends packets which is extended by all the servers. Okay, this is the particular diagram for the broadcast addressing mode. Here we can consider the server A, B and C and the client over there. Okay, this is the particular broadcast addressing mode. Next one is the multicast addressing mode. For this type of multicast addressing mode, it can mix the previous two modes, that is packet it can send is neither destined to the single host or not all the hosts to the segments. And in this type of addressing mode, this packet and the destination address can contains the spatial address which can starts with the 224, and it can be entertained by the more than one host. Okay, this is the particular diagram which is considered for the multicast addressing mode. Okay, next we have to consider the server can send the packets which is entertained by the more than one server, and every network has one IP address reserved for the network number which represents the network, and one IP address reserved for the both broadcast address which represents all the hosts in that network. Okay, next one, it is the hierarchical addressing scheme. Okay, in this particular IPv4 can uses this particular type of addressing scheme, and the address it is the 32-bit length, and it can be divided into 2 or 3 parts. Okay, IP addressing for this, a single IP address can contain the information about the network and its subnetwork and ultimately the host, and this scheme enables the IP address to be hierarchical, where the network can have many subnetworks, which is turn can have the many hosts. Next one we can consider for this particular the subnet mask. It having the 32-bit IP address, it can contains the information about the host and its network. It is very necessary to distinguish for both the addresses. Okay, this is again the 32-bit long, and we can say that 192.168.1 and 152. This is all about the subnet mask. Okay, this is the subnet mask, is the IP address, and the mask and the network, that is mask it is 255.255.255, and the IP 192.168.1 and 152. It can be again, this is the result for. Okay, next one, subnet mask. This is the way of subnet mask. It can help extract the network ID and the host from the IP addresses, and it can be identified in this way, which is shown over here. Okay. Next, binary representation. The positional value of this method, it is the simple form, and it can convert from the binary to the decimal value, that is the IP address. It is the 32-bit value which is divided into the 4 octets, and the binary octet contains the 8-bit, and the value of each bit can be determined by the position of the value of 1 in the octet. Okay, this one is the binary representation. Okay, this is the MSB, and this is the MSB and the LSB. Positional value, it is the 1, 2, 4, 8, 16, 32, 64 and the 128. Okay, and that particular positional value, it is determined by the 2 raised to 2 power. Okay, this is the power, that is the position, and it can value of 1 bit at the position of 6, it is 2 raised to 6. Okay, 2 raised to 5, again it is the 32 bit, and the total value of the octal, it can be determined by the adding up to the positional value of the bits. Okay, that particular table, it can be shown over here for the 128, 64, 32, 16, 8, 4, 2 and 1, and this is the particular value, it is 1 to 255. You can see this is the particular binary value. Okay, thank you.